So let's talk about what's next for the internet. Because we're on the verge of a massive shift. We're moving from an internet of information to an internet of action, where AI doesn't just help us, it acts for us. But that brings up a huge question, right? How in the world do we trust these autonomous systems to do the right thing? Well, that's exactly what we're diving into today. A completely new way to build trust for our digital future. This quote from Sriram Kannan, the CEO of EigenLayer, just hits the nail on the head. You know, for years, people have been saying crypto is a solution looking for a problem. Meanwhile, AI is this incredible rocket ship that everyone's a little nervous about, because who's watching it? What we're about to explore is how these two giant puzzles actually fit together perfectly. Crypto's superpower is creating trust, and that's the one thing AI desperately needs to reach its full potential. So you've got these two worlds, right? On one side, you have autonomous AI, agents that can manage portfolios, run businesses, you name it. And on the other, you have blockchain, a technology that's basically a rule book that can't be cheated. The whole idea here is to bring them together, to use the unbreakable rules of blockchain as the foundation, the safety net that lets us unleash the power of AI without it all going haywire. Yeah, think about it like this. An AI assistant, like the ones we use today, it tells you things. But an AI agent, that thing does things. It could be given a budget to manage your cloud computing or authority to execute trades for you. The second you give it autonomy, the stakes go through the roof. We're talking about real money, real consequences. This isn't just about a chatbot getting a fact wrong. It's about building a system that can be trusted with responsibility, and that's a whole different ballgame. Okay, so if we need this new trust layer, how do we build it? Well, to really get why this new approach, called Autonomous Verifiable Services, or AVSs, is such a game changer, we have to look at the old way of doing things. And the biggest hurdle has always been the insane cost of building digital trust from zero. Every single new decentralized project runs headfirst into this classic wall. It's the ultimate chicken and egg problem. To get users to trust your new service, you need a ton of security, right? You need validators, you need economic guarantees. But to pay for all that security, you need users who are paying you. So you're stuck. You can't get the trust without the money, and you can't get the money without the trust. It's an innovation killer. And here is where everything changes. The old way, man, it was brutal. Every new service had to build its own fortress from scratch. Find validators, print a new token, spend millions just to get a security network online before you even had a single customer. It was slow, expensive, and it created all these little islands of security. The AVS model completely flips that. Instead of building your own power plant, you just plug into the grid. You rent security from Ethereum's massive, already existing trust network. It's cheaper, it's faster, and it lets developers focus on building cool stuff, not reinventing security every single time. All right, so this idea of renting security sounds amazing, but how does it actually work? Let's pop the hood and look at the engine that makes all of this possible. It's a really powerful idea called restaking. So the security behind a network like Ethereum boils down to this concept: crypto economic security. It sounds complicated, but it's not. The crypto part just means we can use fancy math to prove with 100% certainty that someone broke the rules. And the economic part is the consequence. If you break the rules, you lose your money. Your staked tokens get slashed. It's basically a massive security deposit that keeps everyone honest, because cheating literally costs you. But here's where it gets really interesting. Not all mistakes or bad actions are the same. Some things are super easy for a computer to catch. They're black and white. Did you sign the wrong transaction? Yes or no? But what about the stuff in the gray areas? What about a problem that's blindingly obvious to any person looking at it, but that you can't just write a line of code to detect? And this is where the old model really hits its limits. Code is fantastic at catching what we call objective faults, provable errors, but it's terrible at these intersubjective faults. The classic example is a data oracle that suddenly reports the price of Bitcoin is $1. We all know that's wrong, right? But how do you write code that knows the price of Bitcoin shouldn't be $1? You can't. That requires a totally different approach. So that's the billion-dollar question, isn't it? How do you enforce rules against behavior that a computer can't even see as wrong? The answer, it turns out, isn't to write more complex code. It's to build a system that brings human judgment into the loop in a really clever way. And this is the solution. It's pretty genius. It works like a digital court of public opinion. So step 1, a bad actor does something shady that the code can't catch. Step 2, the rest of the community sees it and agrees. Yep, that was wrong. Then, instead of trying to prove it with code, they propose a fork, basically a new version of the system's token. In this new version, the bad guys have their stake taken away, and everyone else is made whole. The free market then does the rest. Everyone moves to the honest version, and the bad actor's token becomes totally worthless. It's a way to use social consensus and money to enforce rules that are beyond the reach of pure code. Okay, so we've got this really clever technical design. But what does it mean in the real world? Well, this isn't just a theory on a whiteboard anymore. This is happening now. And it's creating a whole universe of new services. And I mean, just look at this number, over $15 billion. That is the amount of money that people have already staked in EigenLayer, the main platform for all of this. That's not revenue. That's the security budget. That is the collective economic weight that is on the line, ready to secure this next generation of the internet. It's a massive, massive signal from the market that this is the path forward. So what's actually being built with all this security? We're talking about the absolute bedrock of Web3, the fundamental plumbing. Things like data availability layers, which are critical for making other blockchains scale. Decentralized sequencers, which help make transactions faster and fairer for everybody. It's everything from bridges between chains to oracles to brand new kinds of rollups. This isn't just one product, it's a foundation for thousands of them. And we're already seeing the results. Take Caldera, a rollup provider. By plugging into EigenDia, one of these new AVSs, they're hitting data speeds of 100 megabytes per second. To put that in perspective, that is a huge leap in performance. It's the kind of speed you need to run serious high-volume applications. Think payment networks, fintech platforms, things that banks could actually use, all running on a decentralized, verifiable blockchain. What's really cool is the little economy that's popping up around this. You have the AVSs themselves, who are the customers buying security. You have the operators, who are the businesses running the software. Then you have the restakers. These are everyday Ethereum stakers who can now put their ETH to work in a new way, delegating it to operators to earn extra yields. And finally, you have these liquid restaking platforms that make it super easy for anyone to get involved. It's a brand new marketplace for trust. Now, with this much innovation and this much money flying around, it can't all be smooth sailing, right? Of course not. It's super important that we look at the potential risks and challenges here, because they are very real. And these aren't just minor worries. The concerns go right to the top. Vitalik Buterin himself has warned everyone, don't overload Ethereum's consensus. What he means is if one of these AFVs has a huge failure, there might be pressure on the main Ethereum blockchain to roll back and fix it. And that would be a disaster, because it would compromise the core promise of Ethereum that the base layer is neutral and doesn't take sides in application disputes. And the list of risks is pretty long. There's the classic risk of centralization, where a few big players end up controlling most of the network. For individual restakers, things get complicated. If you're securing 10 different AVSs, you're now exposed to 10 different sets of rules for getting slashed. It's a lot to keep track of. And then there's the big one, systemic risk. If a major AVS goes down, could it create a domino effect that takes down other services with it? These are seriously complex systems, and as security audits are already showing, even a little bit of downtime could cause big problems. So we started with a huge problem. How do we trust the coming wave of AI agents? And what we found is a potential solution, this powerful new model of shared security and programmable trust. But it's clear the road ahead has both incredible promise and some serious hurdles to overcome. The big question we're left with is this it? Is this the foundation we need to build a future where we can truly rely on autonomous systems? Only time will tell, but it's definitely one of the most exciting developments out there.